Good evening, sir.
Good evening.
Good evening, sir.
Nobody else there?
Sir, they both will come, sir. They both will come.
Both are coming. Right. What are we doing? Am I audible?
Yes, sir.
What are we doing?
Sir, 1 second, sir. Just take the note and see. So we're doing a production of electric energy. Sorry, yeah, production of
No,
electric
you
energy.
finished it.
All right. I gave you some
We have
homework,
finished.
right?
Yes, sir. You gave us some homework and I
Yes, sir.
finished it.
Yes,
Completed.
sir. So we didn't finish nuclear energy, sir. We have a little bit more.
No, you finished nuclear energy.
I think we
Yes.
did.
So advantages and limitations we didn't do.
Yeah, that's first, sir. You have to write on your own, right?
Okay, that's fine.
Advantages and limitations. All we did, na? We
You
explained
gave
it
it as
there.
homework,
So
sir.
that was your homework that we
Yes.
have to write it.
Yes, sir.
Did you do that?
Yes, sir.
I did too, sir. So can you just, before they join, just teach the production of nuclear energy again, sir? Like electricity from nuclear energy. I don't understand this diagram.
This diagram.
Yes, sir.
All
Okay.
the diagrams in a physics book are so confusing, sir. They don't even give it simple, sir. They just wantedly make it complicated.
They are really complicated, that is there, but they are really interesting if you get into it. See here, Nitish,
Yes,
uranium rods are there. Uranium rods, they are
yes,
able
sir.
to react. Okay, and between uranium rods, you can see this black one is your graphite rods. Graphite rods are used to cool down, right? So what
Yes,
happens?
sir.
We pump the coolant. What is coolant? Heavy water. Heavy water is our coolant. So whenever this reaction goes on with the uranium rods, there is heat production. So this coolant passes on there, and this is cold coolant from here,
Oh,
and it gets
graphite is
heated up.
not there.
And
Good
hot
evening,
water.
sir.
Good
Good
evening.
evening, uncle. Mute
Sir,
yourself. There's
sir.
so much background noise.
No, it's not from me.
Sir, for if the graphite rods are
Sir,
not there,
sorry,
it'll be
sir.
hot.
I thought the meeting was at
Indeed.
5:30.
No problem.
So,
The meeting just
like,
started.
Just let me
graphite-
explain, please.
if the graphite blocks are not there, it will be hot, and that heavy water is there to prevent that.
No, graphite rods are to control the reaction. They are put in when you have to stop the reaction.
Yes, sir.
Because after that, the
So
reaction
what is
will
the
be
question?
uncontrollable.
Nothing.
Understood? So
It just
after
class
that,
just
the
started.
graphite rod will not be there. This reaction will be uncontrollable.
Yes, sir.
Okay, so this hot coolant, after passing from this reaction, that is this heat of this hot
So it
coolant is
became
transferred
hot
to the
because of the reaction, sir.
pardon?
The coolant becomes hot only because of the uranium reaction.
Yeah, reaction.
Yes, sir.
So this heat of the coolant is transferred to the cold water from these pipes, and that cold water transforms into vapor. That vapor are pressurized to this turbine that rotates and produces the electricity.
So cold water is like inserted from the outside, and that hot coolant is so hot, like it condenses the cold water, and that cold water is produced. I mean, that steam is like the evaporated cold
Does
water is
not condense,
producing.
right? It gets boiled.
Wait,
It gets heated.
yeah, it
Vaporized.
gets heated. So like it
Vaporized.
gets so heated, like
Yeah.
it turns into steam, and that steam is like moving some turbines and producing electricity, like that. So
Right.
oh, okay.
So what
Did
does it
we
have
do
to do
this?
with the elements
Did we
here,
do
sir?
this
We can
last
just
class?
Yeah, I didn't
normally, can't
understand.
we just normally heat it? Why we need those
See,
uranium?
if you will normally heat it, you will require energy, right?
Yes, sir.
And ultimately, what you'll do?
Burn something.
If you heat water, what do you require?
So your voice is lagging
Sir,
a
your
lot.
voice is breaking a lot.
1 minute.
It's breaking,
So
not
what's
lagging.
the purpose of the cadmium rods?
They're just like the holding stick of the.
That means you can use any stick, right? Any rod, right?
I mean, it'll burn, right? It has certain
Yeah,
boiling
then you can
points.
use iron rod.
No, I think so much heat will be produced, the iron rod will melt, I think.
Titanium rod.
There'll be some. It's expensive, bro.
Bro, it's a
Very
nuclear energy, bro.
There are
Everything
some-
that
there are some
expensive, da.
Like,
There'll be some properties that have to be like that. Probably that's why they
yeah,
use.
like
Oh,
there are some
Look, am I
special
audible now?
properties.
makes
Yes,
Am
sense.
I
sir.
audible?
Sir.
Yes,
Now
sir.
see,
Yes.
basically what you require to heat water, you require natural gas LPG or you require electricity.
Yes, sir.
Any form
Sir.
of energy.
So you are producing energy by burning energy, isn't it?
Always
By
they are
burning
getting
coal.
energy.
So that is not done. This
How
is not
can
like
we burn energy, sir?
what
Not
I
burning
mean
energy.
is
That burn is the energy.
you're using energy basically to produce energy.
Okay.
So what's the
So
purpose
final
of the
goal is to
cadmium?
create electricity, but we need that
Final goal is
electricity
what?
itself
Our final
to-
goal is to create energy with minimum loss of energy.
Yes, sir.
So like, how does uranium like heat it, sir? How?
Uranium has that nuclear fission reaction, and that does not require any kind of energy. That is itself
So you
radiation.
just
Radiation is
so
already
you
there.
just keep uranium. So you just keep uranium in hot water. It'll get hot.
Kind of thing is that we cannot directly utilize uranium rocks. We cannot directly go near the uranium rocks. They
Okay,
have high
so
radiation.
like there is some machine
Those
requires
radiation.
no energy, and you just put water in it. It'll
This
come out hot.
nuclear fission reaction goes on, and that fission reaction, because it breaks and into different nuclei, and that nuclei in the due process you get the heat. Okay, and that heat is
So like
utilized.
there is some.
Kind of nuclear bomb it is. It is kind of nuclear bomb, but at a small level. And that's why graphite rods are utilized, because whenever this reaction goes uncontrollable, you put the graphite rod and then you stop the reaction.
Okay, sir.
Yes,
So
sir.
like there's one machine requires no electricity, no energy, anything. You put water in it, it'll become hot.
Kind of thing, yeah. But there are radiations with it, and that uranium will get depleted.
So
Kungwel,
that,
but
what is
for
the
now
purpose
there
of
is no
cadmium
machine like
rods,
that.
sir?
But that is the nuclear reactor. It's a machine.
Okay, today we'll study about greenhouse gases.
So wait. What's the purpose of the cadmium rods, sir?
Where cadmium rod?
The one
They
that's
hold
holding
the
the
uri-
graphite.
they
Cadmium
hold
rod
the
holds the
graphite
graphite
blocks.
rods. Ultimately, they are also used for the same thing
So we can
to
use
stop the reduction.
any rod, sir. It's just more holding.
Pardon?
If it's only for holding, we can use any rod, right, sir?
No. If you use any rod, then the heat will be so that it will just melt it down there.
I
Yeah,
told you.
other rods that can also stand up to that heat, like titanium rod or
Titanium
something
is
like
a
that.
material that stands a quite large temperature and it is neutral and many properties are there. That's why it is used.
Ah, it was the
Bro, that's
exact
And
same
not
thing to
exactly,
you.
expensive.
yeah, that's
So we can use
exactly what
titanium, right?
Gopal told.
We can use titanium stuff like that.
So you can say that cadmium rods are also used to stop the reaction or control the reaction, which is
So
attached
what
with
about
the.
titanium rods, sir? Will that work?
I have not researched on this matter.
Oh yes.
How can I say that whether titanium would do or not?
It can be
I don't know.
anything. They just chose cadmium for some reason.
Cheap and
Cadmium can also be whenever they'll be asking you why cadmiums are used. So cadmiums are also used for controlling the reaction. Right?
yes,
Yes,
sir.
sir.
Sir, but why won't that graphite graphite block like disintegrate, sir, because of the heat?
They also disintegrate. Everything you have to change in due process. It is not like if it has been put, it is
Uranium will
not.
get depleted. Like it'll get
Even
over.
And
uranium.
the graphite will get disintegrated like most of the times.
Okay, now see here, greenhouse effect. What is greenhouse effect?
Yes, sir.
Last topic of
Sir,
this
when
chapter.
the harmful rays emitted by the sun are trapped in the atmosphere due to harmful gases, it's called the greenhouse effect.
It is the process of
They're not necessarily
warming
harmful.
Sir, we have energy degradation, sir. We don't do it.
of planets.
Sir,
We do
there's
that
energy degradation before that, sir.
Energy degradation.
Sir.
Yes, sir.
Yeah, that one topic is there. I thought it was in it. Okay, let's first cover it and then we'll do that. It's not a big deal.
Okay, sir.
Yes, sir.
Warming planet's surface, its lower atmosphere. Lower atmosphere, the atmosphere which is attached with the surface. Okay, lower atmosphere, absorption of absorption
Sir,
of
are we doing greenhouse effect or energy degradation?
Greenhouse
Greenhouse
effect.
effect. Written there, no?
Okay.
infrared
No, I
radiation.
thought I thought you
Okay.
forgot to change
Okay,
the
okay.
Infrared radiations of long wavelength. I'll explain each and every term. Long wavelength emitted out from Earth's surface. Emitted out from Earth's surface. Now see here, what is it happening here? The thing is
What's
that
that fourth word? The
process of warming of planet's surface and its lower atmosphere by absorption of infrared radiations of long wavelength emitted out from Earth's surface. Now see what is long wavelength. You know, energy that you'll study later. Energy of a wavelength of a wave is hc by lambda. Don't ask me what
what's
is h,
lambda?
what is c, what is lambda. Okay, so this is the energy of any wave. Any wave it is traveling, this is the energy of that particular wave. So you
What is
can say that
lambda?
energy lambda is the
Hey,
wavelength.
sir, just told don't ask what it is. It's a Greek alphabet.
Sir, what is H and C, sir?
Sir literally just told don't ask what it is. Da.
I cannot say after this. I have already told you. Don't ask me what is this because this is not a clear level. But I'm just trying to explain you what is long wavelength.
Yes, sir.
So energy from this relation, you see that is inversely proportional to the wavelength lambda,
Yes, sir.
right?
Yes, sir.
Yes, sir.
So energy that means if you increase the wavelength, energy will decrease or not.
Yes,
Yes,
sir.
But
Sir.
don't ask. You have not studied about what is wavelength.
No,
Sir, we
sir.
studied it in sound chapter and we know it's nearly the same thing.
Exactly. You have studied in sound. This is one wavelength.
Crest.
Yeah, one crest and
Sir,
one.
so
One crest and one dress or something.
So if long wavelength means what? Low energy waves.
Low frequency.
Low energy, no. Frequency is different.
No, frequency is different.
Low energy waves. Alright?
sir.
Understood or not?
sir.
This is what it wants
Sir,
to tell.
all
that
energy is in wavelength, right, sir?
Yeah,
Yes.
nothing, sir.
So it says that it is the process of warming of planet, the surface of Earth. Let us say this is the atmosphere level. Atmosphere. This is the surface, and this is the sun. So rays come here, they cross the atmosphere, and they get trapped inside the Earth's atmosphere. Okay, and these trapped like waves, they create the heating effect over the atmosphere. Understood or not?
Yes,
Yes,
sir.
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 And that creates the greenhouse effect. All right.
Yes,
Yes,
sir.
sir.
Now see here. So this was the basic thing, and related to this is the most
Yes, sir.
phenomena, that is the global warming.
I was writing.
I'll let you write global warming. Okay.
Yes,
The most
sir.
related phenomena to this, it is the increase in. It is the increase in average effective temperature. Average effective temperature.
Sir, we finished greenhouse effect. So it's like
No.
2 pages in our.
No, it's a new.
No, wait. Let me teach first. Now,
No, sir.
You're telling
The
us to
book
wait,
is like
huh?
so big. No, I didn't tell you to wait.
Lex,
You told
is
us.
there anything that I have left in previous classes, previous chapter, previous topics? Is there anything I've left?
No.
No, sir.
I didn't leave anything. You just wait here. So related to greenhouse effect, that increase in the trapping of the waves inside the Earth's atmosphere or any planet's atmosphere leads to global warming. Now, what is global warming? Global warming is the increase in the average effective temperature, okay, near the Earth's surface. Why this happened? Near the Earth's surface. The Earth's surface due to increase in the amount of greenhouse gases. Due to
Its atmosphere.
increase in amount of greenhouse gases. These waves, what are these greenhouse gases? These waves get trapped by these gases. These waves
Yes, sir.
gets absorbed or trapped by these gases. Now come to this greenhouse effect topic. After the you just like you put a pencil there, and I'll just speak it out, and I'll ask you to underline the important terms. See there.
Are
Solar,
these waves in form of heat, sir? Are these waves in form of heat?
they are in form of heat, light, and invisible radiations also.
Yes, sir.
Okay. So the solar radiations coming from the sun have high energy radiations such as gamma rays, X-rays, ultraviolet rays, and low energy radiations such as visible lights, infrared radiations, and radio waves. Okay. So according to the statement, what do we say that gamma rays, that is denoted by this sign, gamma rays, then X-rays, then we have UV rays. These are high energy rays. High energy means
Emitted by the sun, right? Sir.
low wavelength.
Sir, that means their
Understood?
sir,
Similarly,
that means their wavelength is long, right, sir?
Yeah.
No, it means it's short.
high energy, low wavelength, inversely proportional.
Oh, I didn't know that.
Yeah.
Visible light,
Told.
infrared, and radio waves. Radio waves. These have low
Sir, how are
energy.
radio waves visible, sir?
No, radio waves are not visible basically. Visible
Yeah,
light is
low
different.
energy
Visible light contains the 7 colors. 7 colors being contained in the visible light. There is a spectrum. Okay. So we have radio waves, radio, then micro, then infra, then we have infrared rays, then visible, then UV, then X, then gamma. So this is the increasing energy order.
Oh,
Increasing
sorry, sir. I thought
energy order.
visible light
Sir,
was
but there
the
are
subheading.
many other
No,
rays
no.
other than these, right?
Basically, we study these only. This is called electromagnetic spectrum. These rays are always studied. Radio waves, microwaves, infrared waves, visible lights. That is the 7 colors come in this range. Okay. Then we have UV rays, then X rays, then gamma rays.
Also have magnetic waves, something like that.
This is increasing energy and simultaneously decreasing wavelength. Understood?
Sir.
Sir.
So these are the different kinds of waves that has been emitted by the sun. Our Earth's atmosphere is transparent only for visible light and infrared radiations of short wavelength. Alright? Then gamma rays, X-rays, ultraviolet are absorbed by the ozone layer itself surrounding the Earth, while infrared radiations of long wavelength and radio waves are reflected back into the space. So if I draw
But
this,
should it be vice versa, sir?
this is Earth, this is the atmosphere. So according to this, only visible light and
Radio
infrared
infrared.
light
Enter inside the atmosphere.
that passes through the atmosphere. Alright. Then this your gamma rays, X rays. You know that I'm using this gamma for this sign. This sign is used for gamma.
Yes, sir.
Gamma
Yes,
rays
sir.
and X rays
Yes, sir.
and ultraviolet light UV absorbed in the ozone layer.
The gamma rays won't be stopped, right?
Absorbed.
Oh,
Absorbed in the ozone layer. And the rest of them, they are reflected back. Which are
Gamma.
reflected back?
Gamma.
Radio waves. Radio and infrared. Infrared of long
Sir, but you
wavelength.
said here that visible light and infrared waves go through, sir.
Study this line.
Sir, but how can these ozone layer is basically made out of O3 molecules, right, sir? Then how can these molecules like absorb energy rays, sir?
See, everything absorbs something and reflects something. Okay, everything has two tendencies. Have you ever studied why anything looks of that color which it is? For example, why leaves look green?
Because of the chlorophyll.
Because of chlorophyll.
Why chlorophyll?
What?
I don't know why
Why
chlorophyll.
roses are red?
sir.
Why sunflower is yellow?
Sir, what?
Why
Personal
roses are
choice?
red? Why sunflower is yellow?
Personal choice.
Sir, it's because they don't reflect that color, sir.
Reflect that color and rest all the colors they absorb.
Yeah, sorry. I
Whatever you
flipped it up,
see,
sir.
they reflect that, and that attacks your eyes, and that's how you
It
see
can't
it.
absorb red.
Yeah,
So
the
it
color that you
reflects
see,
it.
they can't absorb that, and rest all the colors they are absorbing.
What about
That
blue?
goes this way. Understood?
Blue, same thing. Yes, sir.
So this is there. Okay.
Yes.
The gases are good absorber of the long wavelength infrared are called greenhouse gases. Greenhouse gases. Gases which are good absorber of infrared radiations of long wavelength.
So the ozone layer and the greenhouse gases are the different
Kind of,
layers.
yeah.
And greenhouse gases can absorb infrared rays, but ozone can't.
Exactly. So what happens whenever the example there's CO2, then we have chlorofluorocarbons. Okay. Then we have methane and water vapor.
Sir, but how do these chlorofluorocarbons damage the ozone layer, sir?
Oh, whoa. How?
They don't damage those rays. What happens there? Ozone layer tries to reflect the infrared of long wavelength. This is the condition of ozone layer. But these greenhouse gases, they try to absorb that. They try to let them enter through the ozone layer, and that's how they create the hole there. and they, after creating the hole, that infrared radiations come inside and they absorb it. And that's how these radiations, there are more radiations than coming inside. So these radiations increase the temperature because they comes with the heat also of the sun. Understood?
Yes, sir.
All right.
Yes, sir.
Yes, sir.
The figure is
Yes,
important. Greenhouse gases.
Yes, sir.
So what is naturally occurring greenhouse gases have an average warming effect of nearly 33 degrees Celsius. So average temperature on Earth is about 15.5 degrees Celsius. In absence of greenhouse gases, the heat energy radiated from the Earth's surface and its object, it would escape into the space, and the average temperature would fall to minus 18 degrees Celsius instead of being 15.5 degrees Celsius. Underline this line. The natural occurring, from natural occurring to the end of the paragraph. Did you see
Are you
that?
writing something?
Yes, sir.
No,
yes, sir, it's in italics. It's in
the
italics in our
italics
book.
part, the natural occurring greenhouse gases, that italics part. From there,
So
till
you
the
said
end of the-
something else, sir. Negative 18 degrees Celsius and
That's there. That's
No.
there. So basically, what happens in small amount, these greenhouse gases are important. The basic thing, in small amount, these greenhouse gases are really important.
Like CO2 for like photosynthesis and
It's
all.
in page number 159,
No,
right?
basically to contain the temperature also. Otherwise, what will happen now? If these greenhouse gases will not be there, nobody will be there to absorb the radiations and to maintain the temperature of the Earth. Otherwise, what will happen? The heat of the Earth, because Earth also dissipates heat, even we dissipate heat, isn't it? That's why we need cold. So this dissipation of heat will go into space, and no heat will be there surrounding us, and that average temperature around us will fall to minus 18 degrees Celsius. Should
So greenhouse gases
Yes,
are
sir.
important and too much at the same time.
But the thing is that too much of it, more of it is what they are doing. They are increasing the average temperature. If they are
More of
increasing the
anything
average
is
temperature,
dangerous.
what will happen? They'll melt
Too
down
much
the
of
ice caps.
anything, good for nothing.
Yeah, you.
They'll melt down the ice caps, and ultimately, if the ice, all of the ice caps will melt down, then we won't have any water to drink.
Yes.
All right.
So
Homework question. What are the human activities? I just want you to study this book, this chapter particularly, because lots of theories are there. What are the human activities responsible for? That's why I'm giving you these typical questions. Responsible for increase in
greenhouse gases.
CO2.
Oh,
CO2 gas.
that's a pretty easy homework. Sir.
All right.
Yes, sir. I don't even have to do it, sir, because we've been doing this for ages.
To read this chapter and then give the answer. So this was all about your greenhouse effect.
Yes. Sir.
Now we have future projections also. Future projections is what we are thinking, what we have decided. So we can see that the temperature of the Earth has risen 0.74. That means 0.18 degrees Celsius per decade.
So the book is
So
so
rate
much
of
about
increase of this
human.
decade is 2.5 degrees Celsius per decade. So that rate of increase of temperature due to the absorption of absorption of waves by the greenhouse gases, they are increasing, right?
Yes. Sir.
Rate of absorption of waves are increasing. That means more and more greenhouse gases are being released in the atmosphere, and that is increasing the temperature of the atmosphere. That is not good. Okay, so you'll read that para and you'll understand this. Next is global warming. Now, next question: what are the causes of global warming? I'll explain this and you'll write this. What are the causes of global warming?
So there are so many causes of global warming in the book, sir. There's like 3 pages of global warming causes. Sir. Actually 2, but
No, there's
See,
only
circle
one.
that para.
actually 2.
there are three. There are three causes
No,
of global
complete.
warming.
There,
I said
Three
three
I'm
causes.
explaining the causes of
Three
global
causes
warming.
of
2.
there is only three causes of global warming. Only 159.
See there.
Because
After those three, impacts of global warming have started.
Sankalp, shut up.
yeah, sure.
So the concentration of carbon dioxide has increased up to 25% due to industrial growth. So we are releasing carbon dioxide as a really huge extent, right? So that carbon dioxide is increasing. Carbon dioxide is a greenhouse gas, and that greenhouse gas is absorbing more of infrared radiations, and ultimately they are increasing the temperature. Next, concentration of methane has been doubled in the agricultural sources. So methane has also been doubled. Methane comes generally from the bio waste. For example,
Yes,
cow
sir.
dung. For example, humans. For example, agricultural waste.
sir.
They produce the methane. Understood?
Yes, sir.
So that methane is also being released in a very huge extent because the population of the earth is increasing. Third one is the concentration of chlorofluorocarbons. Do you know that where chlorofluorocarbons are used?
Yes, sir. They're used in refrigerators.
Good. Where in refrigerator?
In my house,
House.
Where in refrigerator? Where
in
refrigerator?
the back part,
Right.
exhaust.
No.
In the refrigerator
Sir,
part.
in order to like
To
cool
cool
the.
down, sir. To
Yes, where it is.
Oh,
That,
I thought
have you
refrigerators
opened
are
your
used to heat up.
have you
My
ever
bad.
opened your deep freezer?
Deep
Yes, sir.
Yes,
freezer.
sir.
Deep freezer, and
Freezer,
have you
basically.
seen that vapors and that what are the liquids that are going there, and then it
Yes,
freezes
sir.
down?
Yes, sir.
And
Yes,
have
sir.
you ever seen your mom or dad cleaning the water of the refrigerator from the back?
No, sir.
Today you just go and see there. So what happens there? There's a gas there inside the chamber. There's a gas chamber inside the refrigerator. That gas releases the chlorofluorocarbons inside the your deep freezer, and that gas condenses the air present inside it to the regulated temperature. That is chlorofluorocarbons.
If I close my house
And
totally
also
for like
in
1 whole
ACs.
year,
We
I'll
also
die.
use the chlorofluorocarbons in ACs. We are
Yes,
using
sir.
them, and the selling of the refrigerators and ACs are increasing day by day. So ultimately, what we are doing, we are just taking it for granted.
Yes.
Right? Next is
But
what
we
are
are
the
asking for
impacts of
ACs
global,
in school.
impacts of global warming? Impacts
Hello.
of global warming. Am I audible?
Is that
Yes,
something?
sir.
Right. Next topic is
Stop so much
impacts
saying
of
hello.
global
We
warming.
can hear you.
No, sir. Sir's voice goes like.
Actually, I'm in college, and the
For us,
Wi-Fi
it's so clear,
here
sir. For us,
is
no.
quite low.
For me and all, it's
Oh,
clear only, sir.
Right. So,
Like
am I
it
audible?
breaks
Am I
or
audible?
something.
You're clearly
Yes, sir.
audible,
yes,
sir.
sir, very much audible.
Now, see there. What are the impacts of global warming? So, what are happening? What are the things that are happening in the nearby? Did you see that Apple launch yesterday?
Launcher. What?
Yes, sir. Yes,
Yes,
sir.
iPhone
Where do you
15.
find
Apple.
this?
They they manufacturing in Chennai.
What is that?
I think in Hyderabad or Chennai. Chennai.
But what is
It's
Apple launcher?
Chennai, sir. Saw news yesterday.
Sir,
Today,
Apple.
Apple is launching iPhone 15.
Yeah,
The
iPhone 15.
Apple, that
Christmas.
Apple.
Oh, what
Yeah.
I want to ask you about? Did you see that launch yesterday?
So they burned everything.
Yes, sir.
Launched
No, sir.
yesterday, and
I know it got
that
launched.
launch. Did you see that launch
Sankalp.
part?
Not exactly, sir.
No, sir.
Right. So what they did in the launch, you just go to that launch in YouTube. They would be there. That would be there. That video. So they try to explain that they are working really on carbon zero work function. They are not like producing any kind of carbon there. Or if they are producing, they are eradicating it also by planting trees. Because the Apple that head office that is there in Silicon Valley, that is 100% like this renewable, working on renewable energies. Energies are there, wind energies are there, and they are 100% working on the renewable energy. 100%. They claim that.
Especially like Apple.
So that they are working on it, because it is really a very great topic, a very great that we can say that concern, matter of concern nowadays. See the impact, the variable changes in the climate, different parts of the world which are they created difficulties and force the people, animals to migrate. Second, the change in the blooming season. Third, the change in the regional climate, change in the world ecology, and the change in heat stroke deaths. See, have you ever seen that in the last few years we have been increased the temperature, average temperature of the earth? We have more hot summers, more cold winters. irregular rainy seasons.
Yes,
Have
sir.
you heard about this?
1%, 1 degree per year. That's like so much.
Have you ever heard about this?
That is so
Yes,
much.
sir.
It's like accumulated.
These are happening due to this thing only.
Phone.
Due to this thing only, because our Earth is regulated for a natural environment, but we are alternating it by our artificial made machines and all. Understood?
Yes, sir.
Goes this way. Now, future predictions. With the present rate of increase of greenhouse gases, global warming, it is predicted that the average temperature of the Earth's surface will become 64 degrees Celsius at the end of 2100. See, 60. We cannot sustain more in conditions more than 40 degrees Celsius. 40 degrees Celsius is too huge. Do you agree?
Yes.
Yes, sir.
And they are saying that it would be 64 degrees Celsius. Although it is not possible to make very accurate predictions because that depends on our nature. If we work on together and work like Apple, so we'll be like doing it earlier also. Got it? Now,
Yes, sir.
Although it is not possible to make very accurate predictions in the impact for the future, but still looking for the changes some natural phenomena will be facing now, following predictions can be made. If we are to continue with the same condition till 2100 century, 2100 year, so what will happen? See that dislocation and disappearance of many plants and species, animal species. One thing. Second, warming of ocean, they'll get heated up, melting of glaciers, and shift in the farming region, increase in new diseases, health, heat-related diseases, then change in the regional climate, variable change in the climate, increase in cost of air conditioning, because more temperature will be there, more electricity will be required, change in the sea level, all these things will be happening. Understood?
Yes. Sir.
Now we'll be seeing the ways to minimize the global warming, how we can minimize. So first is technological measures. What are the technological measures? Use of renewable energy, like what Apple did. Understood? Second is economical measures. So what we can do, we can like disgrace people by using excess of electricity and excess of energies, excess of vehicles by increasing the price. That is the tendency of government. Every government do this. They increase the price of the petrol that much that you just disgrace yourself by using vehicles, isn't it?
Yes. Sir.
If the vehicle prices rises, if the petrol prices rises, what is the general tendency of the people? They try to avoid using bikes for short distances. They try to walk more, isn't it?
Just make everything expensive and then they'll stop using bikes.
These are the economic measures. Then policy measures. We can policylize these things. How we can policylize? Okay, we'll see it later in detail. So technological measures contains of use of renewable energies for electricity in place of electricity based on fossil fuels or power plants. Next is change of transportation vehicles. We can, instead of using petrol run vehicles, we can use the like electric vehicles that has low emissions. CNG
Sir, but
vehicles
it's
that
hard
have
to get
low
so many batteries, right, sir?
Yes,
Yeah,
sir. That will cause a lot of pollution, right? That's
No.
more pollution.
Where?
Sir.
You have to
if,
mine lithium and other
yeah.
substances, right?
So we have found the biggest reserve in India for lithium, and if that production started there, though we'll be getting the batteries in a very cheaper price, and ultimately the prices
Sir,
will be
but
low.
that's more
Itself is
pollution, right?
polluting on the first place.
Sir, it's like if you want an eco-friendly, you indirectly have to pollute some way or the other.
How that will be
Lithium is
polluting?
the only thing we are polluting. That's
Lithium
it.
or batteries, how that will be polluting?
Except lithium, we are not polluting anything else.
Sir, for like
Hey, we're
if you
minimalizing it.
battery-
There's nothing that can't be produced with zero waste. It's nearly impossible.
Exactly.
Something will be wasted.
And on
We
the
have
other
to
hand,
compensate it with other means.
on the other hand, we are
For
still
our
working on it.
pleasure.
We are still working on it.
That's what I said.
Next thing is that economical measures. Okay, before that, use of biogas stoves for cooking. So instead of using those LPG vehicles, we can use the gas stoves. What are these? So methane gases can be stored in a chamber, and then that can be used. Gobar gas plant. I showed it to you, right?
Everyone uses.
Right. Next is economical measures. So reforestation, industries to pay carbon tax. See there. Industries to pay carbon tax. If they'll be paying more and more of carbon
So
tax,
it's actually
whatever
like a very, very smart plan, sir.
Yeah,
No one is
if they
checking this.
are planting, if they are paying more for carbon tax, so they'll take measures so that less carbon get emitted from the plant. That they try to pay less, isn't it?
Yes, sir. It's actually so smart.
Right. Next is policy measures. Policy measures can educate our children, our future generation, to live sustainable lifestyle instead of wasting. Next, controlling population through the family planning, because population is also somehow responsible for the global warming, right?
So,
Recently, in 21st, that last paragraph you underline, 21st yearly 2015 United Nations Climate Change Conference held in Paris from November 30 to December 12. Each nation has expressed a deep concern for the present rate of increase of greenhouse gases and limit to the global warming to below 2 degrees Celsius compared to pre-industrial year, which is the zero. They have just planned for this. Okay, they are sat down in a conference and they decided that they'll be targeting this and they'll be they'll be taking the controlling measures in order to achieve this achievement. Understood or not?
yes.
Yes, sir.
This is how your chapter ends.
What about conclusions?
Just theoretical here. I try to explain each. Okay, one more thing. This energy degradation, na?
Yes, sir.
Okay, energy
That's
degradation.
easy to understand. Sir.
Let us complete that. Energy
So where
degradation.
is that that all the, like you said, all the countries has come to like something?
Next
Somebody
page,
tell him.
last page.
Where is it?
Last paragraph.
Oh, okay.
Yes, sir. You can do energy degradation.
All right, 1 minute. So gradual decrease. It is the gradual decrease of useful energy due to radiation. Energy due to radiation loss, is called the degradation of energy. So as we studied, what that what do we say that we cannot produce 100% efficient plant, right?
Yes, sir.
So, like radiation, like
Uh,
the machine friction.
there are something that is where the energy of the particular machine, the input energy, gets dissipated. Agree?
Yes,
Mhm.
sir.
That particular process is called energy degradation.
Mhm.
Just like that thing. What is write its example? Okay. So basically, you see that whenever we light a bulb, so 25% of the energy of the bulb that is being provided with the electrical energy gets converted into light energy. The rest 75%
Just goes like
that gets
heat.
into the heat of the bulb.
Heat.
You remember that yellow bulb used to come from the tungsten wire
Yes,
long time
sir.
ago?
That wire is
Why
Like
that got
100-watt
discarded?
bulbs.
Why that got discarded?
so because it's like too much of the energy is being
Sir, it
degraded.
heats the rod in the middle, which produces a very bright light.
See there, 100% of energy that you're providing as the electrical energy, only 10% of it was used to convert it into light, and rest 90% were used to heat
Too
that
like
particular wire. But do
energy
we
would
require that heat? Do we require that heat? No.
no.
No, sir.
So that was not
Unless
used.
you're
Now
not
we are
talking.
using this CFS and we are using this LED bulbs, and they are converting around 50 to 70% of the electrical energy into light. So that's why they are producing more light and they are burning less. Feel less heat there, isn't it?
Yes, sir.
So it goes this way.
So, but that whole purpose of that bulb was like it should produce light because of the heat, sir.
No,
Yeah, but do we require that heat? That heat was not required by us,
The
na?
heat is
the
not required, but
byproduct.
like in the olden days, they had no other way.
That is energy degradation.
Yeah.
Where
Now
you
we
did
are
not
smart.
use that energy and that got degraded.
Yes. Now we are smarter, so that's why we found out better alternatives. Back then, they didn't have that much resources.
Now you go through this last topics once again, turn your pages and see whether any topic is left or you want an explanation over any topic. Do it. Seriously do it, because this is theory and you need to write in exam long answers. It is not numerical.
No.
And you are going to get this, what do we say that?
In the exam.
Exercises, questions, some DPs, practice questions. Okay. So that DPP is solved, and next Monday we'll be revising. We'll be doing the doubts there. All right.
I have one doubt, sir. Now,
Go on.
can you explain what geothermal source of energy is again?
See what happens at some places inside the Earth's surface, water is present and large amount of heat is there. Maybe due to the volcano or some lava that is present near it. So that creates a large amount of heat, and that water transforms into your steam. So whenever we dig hole there, that steam comes out with pressure, and that steam, instead of just letting it go, we take it into a pipe and then transfer it to a turbine that runs, and then it creates electricity. Geothermal. Geo means earth. Thermal means heat. So geothermal, heat from earth.
Yes, sir. But how do we know there is a patch of steam before putting on
There
the
are
turbine?
like geological surveys. Surveys are done, and they have the machines that tells that below this part of the earth they'll be having that.
Sir, what have you written in energy due to packed reaction?
Pardon?
So what have you written gradual decrease of useful energy due to
Radiation,
I could not hear you.
radiation loss, friction.
Huh?
I could not hear you. Sorry.
So you're asking what's written after gradual decrease of useful energy due to
Okay. Where?
Energy degradation.
Gradual decrease of useful energy due to radiation loss, friction, etc. is called the degradation of energy.
I'll just check all the things I have anything. I do not have any more doubt.
Read it carefully.
Yes, I'm reading it again.
So can you like repeat energy degradation again, sir? Hello.
Yeah, I think he's like taking time to unmute.
Yeah. Any doubts?
Sankar has a doubt.
Yes, sir. So can you repeat an energy degradation again?
See, like whenever we work, whenever we put energy to any machine, so that we need to get any desired output. So all of the energies that we put is not utilized to get that desired output. Are you getting my point?
Yes, sir.
So that the part of energy that is utilized somewhere else. For example, we are working on machines. For example, we have made a machine to crush the garbage. Okay, does that make sound?
Sir?
The crusher of the garbage, does that make sound?
Yes, sir. It does, sir.
Do we require that sound?
No, sir.
But some part of the energy is getting into the production of sound.
Yes,
Understood?
sir.
So that energy which is utilizing somewhere else, that is not required. So that is the degradation of energy.
Yes, sir.
So I wanna know. I have also a doubt, sir.
Go on.
So I have a doubt, sir. Like, what's the difference between ocean as a source of energy, tides as a source of energy, and flowing water as a source of energy, sir? They're all pretty much the same, right, sir? Tides are there in the ocean, and that is used as. Oh wait.
Useless, sir.
Okay, not no. I never said use. No, sir. I do not have a doubt, sir. I just now read the thing. Ocean thermal energy. I got it.
Sorry, actually, I was
No,
just
sir. I do
checking.
not have a doubt, sir.
Yeah, go on. What did you say that
No, I do not have a doubt, sir. No.
water energy? I heard till that, and then that
Yes,
internet went
it's
off.
like I don't know the difference between ocean as a source of energy and tides as a source of energy, sir.
See, basically, these are quite relatable, but two different things. Tidal energy is what are due to why tides are formed. You know that?
Like moon,
Yeah,
something.
moon. Moon attracts the water, and then it wherever it attracts, so that water rises up towards itself, and otherwise it is down. So that rise travels.
Yes, sir.
So that's how they produces tides. So that tides are required. The tides, okay, they flow, and then they may be used to run the turbine or something like that to produce energy, because it contains some kind of kinetic energy, right?
Sir.
Sir, can you repeat what you told now? Yeah.
So I'll explain, sir. Yeah, I understood.
What?
See, Tarun, tides, right? They are caused because of the moon attracting the water, right? Like go up and then down. Huh?
Yeah. Yeah.
Because of that, some kinetic energy is produced, right?
Okay.
That kinetic energy is used like on a turbine to produce electricity. That's how tides are.
Now another thing is that ocean waves are formed due to the wind. The surface part of the ocean is contact with the winds, wind flows, and same with the ocean waves. They are formed due to the wind. So two things are there. Tides are different, and then the ocean waves are different.
But how do we
Ultimately, they both can be used the same thing. Use the same thing to create the energies.
oh, but how do we differentiate tides and waves? How do we know which one is waves, which one is tides?
See, the
They're the same
waves are
thing, but
local. Waves are local due to the local winds. Tides we can predict. Tides are due to the movement of sun, so we can predict that where high tide will be there, where low tide will be there.
Oh,
for example, like if you jump in a pool, it produces a wave, no, like at the corners.
That is
That is
local.
wave.
Okay, so if you don't have any doubts, shall we keep it for today?
yes, sir,
Yes,
but we
sir.
have
Right. Next
5
time we'll be
minutes.
starting with a new chapter and discussion of the DPPs and these
What?
homeworks, right?
Yes, sir, I did.